Hello everyone, welcome back to the channel. So this is the continuation of the data structure algorithm series, and in this video we'll be learning about how to add the node at the end of the list. So for that we'll be implementing one method called as add last, right? So as you know, we have discussed about the introduction of the linked list, right? What is the data structure and how you're going to implement it on your own, right? But we haven't actually implemented yet. So this is where we'll be beginning with the implementation. So we understood in the last video that linked list uses a concept of nodes. Multiple nodes connected with each other in sequence is what is called as linked list, right? So we'll be implementing that node also with help of class. We'll be implementing that add last method, how this particular method is able to add node in sequence in the list. So yeah, let's begin with the implementation. So what we need first is a node class, right? We can create a node class outside as well. Let me create it outside, then I'll tell you why I'm taking it inside. Class node. So we learned in last video that node in singly linked list, node will be consist of two things. So the first part will be the value, and second part the address of the next node, basically the node itself. So for the first part, let's have that value, private value, and the second part will have the node itself, basically the address of next node. For now I'm giving it the name of next. And whenever we want to create a node, right, we want to provide a value. Without value we don't want any node to be created. So for that I'll just create a constructor for it, so that whenever this node is created, right, it will force us to provide a value. This dot value is equal to value. Yeah. That's it. But currently, as you see, it is outside of this particular class, our custom linked list, right? But I think we should move it to inside class. The reason, because this node class, we are assuming we will be using it as a internal functionality only to implement this linked list. It won't be used outside of this particular class. So it doesn't make to have this class as a separate class. So let's focus on that method, that is public void add last method. So in last, we want to obviously provide a value for the node to be added. Now in linked list we talked about those two parameters, right, head and tail. First node is actually head and the last node is tail, right? So these two pointers we'll be using here. Let's say node and have it as head, which will point to the first node tail, this will point to the last node. Now let's say for now you have a empty linked list, right? That means if your head is equal to null, that means you want to set your head and tail both to the new node that you're creating, right? So anyways, as we know, linked list can grow and shrink dynamically. So let's create the node already. New node is equal to new node with the value that we have provided in the method argument itself. Yeah. So this condition will only execute when the linked list is basically empty, right? We are checking if head is null, obviously your linked list is empty, it has no elements. But what if it's not null, right? You have some elements already in your linked list. In that case, what we want to do, So as we already know, right, tail is the last node. We want to add the new node in the last node itself. So tail is the last node. We want to add the new node as the next node of the tail node, right? Don't worry, I'll be showing one graphical representation for this as well, so that you will understand in a better way. Let's focus on the code first for now. So the last node currently, which is a tail node, we want to add new node as the next node of it, right? But we learned already that tail should point to the last node, right? So we'll change that pointer now. Now tail will point to the new node. Basically new node will be the tail node now, right? So that's it, we are done with the implementation. Let's check whether our implementation is correct or not. Let's create our linked list, new linked list. Now list dot add last 10. Let's add 3 nodes for now, 20 and 30. Now let's try to print. Okay, I'll show you one thing. So if I try to print this, right, as we have created this list object, right, so it will print something like this. This is basically hash code of the object that we are trying to print. It will not print 10, 20, 30. So we can create a method for it, like print method, which will, you know, use this particular list to print those individual elements. But for now I want to show this list through debugging, right? So let's see if I can show you that with the help of debugging. Okay, so currently we are at the last line, this println line. That means these elements are already added to list. Let's see if they are added properly or not. This is our list, right? We have head and tail. These are the ones, head and tail, right? These are the two same parameters. So head, I already told you that head will point to the first node and tail will point to the last node. So head should point to 10 and tail should point to 30. Let's see. Okay, so head is pointing to 10 and head next pointer should point to 20. It's pointing to 20, that's correct. It's next, now 20's next pointer should point to 30, which is point to 30, and this is the tail last node, so this should point to null. As you see, it is pointing to null, and tail should point to the last node, which is 30, so this should be 30. Yeah, it is 30, and next node is null. So with the help of this representation, right, with the help of this debugger, we can know that our list that we have implemented, right, is absolutely correct. So this add last method is working properly. Now let me show you a graphical representation also, so that if you have any doubts in the implementation or anywhere, right, in this method, that would be clear. So let me show you that. As I told you, we have 2 pointers, that is this head and tail, right? And currently if you see, these head and tail are null, right? This is where I'm talking about, these head and tail both are null, right? No, so now let's say you have added the first element, which is this 10. Now currently in memory you have a single node, which is this 10, right? Now its next pointer leads to null, and now your head and tail currently both pointing to this 10, because you have a single node in the list. How both head and tail pointer are pointing to 10? Because of this line of code. Let me highlight that for you, right? This line of code. So here if you see, we have written this head equal to tail equal to new node, right? That's how this 10, these head and tail are pointing to 10 itself. Now when you are adding the next node, which is 20, right? So when you are adding 20, this if condition is basically false now, right? Because now head is not null, right? So you will just skip this condition and you will come to these lines basically. So now tail dot next will become new node. That's what we have done here, right? So now this next node, it became this 20 became the next node of this 10, right? And what we are doing in this last line, we are making new node as tail, right? So that's what this cross marks mean here. This, right? This is no more our tail node. Now tail points to 20, right? So our head points to 10 and tail points to 20 now because of this last line, right? Now let's move on to the next node, which is 30, right? In a similar way we have added 20, same way we will be adding to this 30 as well. So now as a next node of this tail, right? Tail dot next is equal to new node. That's because of that line, it is adding 30 as the next node of 20, and this tail is equal to new node because of this line. Now 30 is our tail node, right? Now head is pointing to 10 and tail is pointing to 30. Now this is our final list. So I hope you are able to understand how this add last method is working, right? Initially we had head and tail both null. Then for first node, head and tail both point to 10. For second, tail dot next 20 became the next node of 10. Now tail points to 20. Now we added 30. Now 20 next node became 30 and now tail points to 30. That's how the add last method is working. So I hope you are able to understand this implementation, right? It's very simple. Okay. So in that presentation, right, in that UI presentation, I hope you will be able to understand how it's basically adding each and every element just after that previous node, right? So that is the implementation of add last method. In the next video, we'll be understanding out how do you add a particular node in the beginning of the list. For that, we'll be implementing a method called add first, right? So I hope you are able to understand this particular implementation. How do you add a node in the last of the list, in the end of the list? That's it. I hope you are able to understand this particular video, right? See you in the next video. Meanwhile, may the source be with you.